Hey, very good morning. This is Jack here from ProSoft. ProSoft is now doing business as Kelton Tech. Thank you so much for one and all in joining this webinar. Yogesh is going to be our coach today, who is going to um talk about our skills and expertise. We have around the subject we are talking, intelligent business operations with Apama. I thank you one and all, and I request you all to just be on mute, and we have a question and answer session at the end of this webinar where we could answer any of your questions you might have. You could just place it in the box you see, uh, a chat box I'm talking about. So with this, I'll just take a minute quickly to give you an overview about what ProSoft is, or I should say now Kelton Tech is. So we have been doing, or I should say we are in this industry for more than 2 decades now. We started in 1993. If you see, we are headquartered in USA, where we have different um, setups. It could be in Chicago, it could be California, New Jersey, and India. We have an offshore, huge offshore center where we operate from Gurgaon and Hyderabad. So with this acquisition, we now stand at 1,000 plus associates or 1,000 plus employees. And as I said, we are a public limited company now. And out of these 1,000 plus associates, alone in USA, we have 300 consultants working alone in the integration practice. And the rest, we have a strength of 700 back in India. Next slide, please. So this is a quick snapshot about how or the kind of industries we serve, right from web to to mobility, SMAC, IoT, and what we are into ERP and EAI. So this is a quick snap which talks about the kind of industry expertise we have, where much of our revenue, I should say more than 80% of our revenue, comes from the list of technology or industry. You see here in this slide, right from retail to healthcare and life sciences. Next slide, please. This is a partial list where we have been, in fact, this is much more than what we have. This is just a huge logo we have added in retailers to manufacturing to energy to financial services. These are our few of our big clients where we have done business, and there are few where we are currently or actively still doing business with them. And these are our technology expertise. We are in this industry for more than 21 years, serving IBM and SoftwareAG, but into MuleSoft and other platforms, we have been just putting our footprints recently. But we have expertise, or I should say that though we may not have done a lot of implementations, but we have some subject matter experts and some certified people sitting around on the listed platforms, right from MuleSoft, Informatica, CA Technologies, and Red Hat. But within SoftwareAG and IBM, we have been doing this for years and years now, where we do a lot of end-to-end implementations to upgrades and even helping clients on the resource needs. Next. So with this, I hand over to Yogesh. Once again, Yogesh is our senior consultant, and he's going to quickly walk through this. There's a demo, I believe, as well. So all yours from here, Yogesh. Thank you.
Hey, thanks for the introduction, Jack. So we'll start with today's topic of discussion. We know nowadays the concept of computing has moved on from the traditional devices like smartphones, tablets, or your computers to cars, washing machines, and refrigerators. And now these devices are continuously connected with the real world, and they exchange information with each other. As per a Cisco study states that by 2020 there will be about 50 billion connected physical devices powered by 1,000-time increase in the internet traffic. This is huge number of devices acting as real-time data sources. They're creating stream of fast-moving big data. It can be a market data, sensor data, or mobile data. And since this data is moving very fast, you get a very narrow window of opportunity before that data loses its value unless you act on it. Let's elaborate on this thing further. Consider a real life scenario where there is a thief at your house. Now the question is, when you would like to know about this event so you can take effective and corrective action. If you look at traditional way of computing, it will store this event in a database, then run a query at the end of the day to generate a daily theft report. And this way of handling business critical information in such situation is almost useless. By the time you come to know about the thief and this event, it has already happened and you cannot do anything about it. Now consider another alternative to this scenario where you can get immediately notified about this event on your smartphone when this is actually happening. Or still better, directly dialing 911 or such system and providing this information to law enforcement office so they can take the immediate action. The choice between these two options is very obvious. And since this data and insights are only valuable if you can detect and act on them right now, that's where streaming analytics platform can help. So we can simply define streaming analytics platform as a software that can filter, aggregate, enrich and analyze a high throughput of data from multiple live data sources and identify simple and complex patterns to visualize business in real time, detect urgent situations, and automate immediate actions. So it's all about knowing and acting on what's happening in your business at this very moment. You can use streaming analytics platforms to visualize your business in real time. These platforms typically have dashboards which can help you visualize, monitor, and make sense of incoming data from multiple sources in real time. The platform will provide you tools to design and build command center style dashboards for human monitoring. It can feed other dashboards and visualization tools and custom monitoring applications through the APIs. The platform will help you detect urgent situations. So you can define complex analytical patterns of urgent business situations. And since these events happen in real time and you have very small window of opportunity to act, these are categorized as urgent situations. And last major feature is automating immediate action. So instead of just looking at the dashboard or visual description of the event, this platform also help you take immediate action on that event. It can issue alerts to human through email. You can send text or push notifications to other applications through message queues or service calls. Or you can trigger a business process as well. So the features provided by real-time streaming analytics platforms are a little bit different than traditional business intelligence applications. So they provide you a filtering mechanism where you can narrow the incoming stream to include the data relevant to the application. Now this is very important because since the streaming data is like very fast moving big data, it will certainly contain irrelevant information. So filtering is very critical feature. The platform gives you aggregation and correlation feature. You can combine data streaming from multiple sources and it allows you to combine multiple streams into one stream. For example, correlating IDs of newly opened bank accounts with the high volume of transactions to detect a fraud. Due to mobile devices, sensors and fitness bands and things like that, there is a lot of location data streaming from vehicles, machines or people in motion. The location and motion operators built into these platforms allow you to define location and motions of interest. For example, identifying that your regular customer is approaching a coffee shop, so you can keep his favorite beverage ready. Time window is another crucial feature. Since the data flows in real time, but our application only needs a snapshot of the stream in a certain time period. So these platforms provide you sliding time windows to define a time period and the streaming data to include in that window. So the window can then be used to perform time series analysis in real time, such as running totals or weighted moving averages, etc. The platform typically identifies interesting temporal patterns as well. So like arrival of event A followed by arrival of event B within certain time period like 10 seconds. And these patterns are only useful if these events are correlated with each other in a certain temporal order. Streaming analytic platforms provide data enrichment operators which can help pulling reference data from database. So this needs no further elaboration. Actually, this is obvious. And the last feature is query and action interfaces. So the result of streaming analysis is to take action or provide the information to another system so it can take an action. So action operators allow you to send alerts or call services in other applications that in turn can kick off other actions like business process or send email or text or call a service, etc. So the question comes in our mind is we already have business intelligence product already in place in our house, and why do we need this different why are you calling it as IBO, intelligent business operation? How real-time analytics is different from traditional BI? So the purpose of real-time analytics is different than performing BI processing on historical data. Because BI processing caters to the analysis and interpretation of your historical data. So you have something in your database or data warehouse, and then it tells you what has happened in the past. Whereas real-time stream of data tells you what is happening right now. So traditional BI generally has a static data, high latency and relatively slow response. You run daily, monthly, biannual reports. The queries are relatively simple, whereas real-time analytics works on a fast-moving streaming data, has a very low latency. You're processing millions of transactions per second. It needs to match certain complex and simple events, and it's a continuous execution, unlike batch processing happens in the traditional BI. So here are some typical real-time streaming analytics scenarios like airline traffic monitoring, stock market trading, targeted marketing to retail customers, monitoring your in-house infrastructure with the help of sensors, detecting fraud based on patterns, monitoring credit card transactions to detect suspicious activity. So in the previous slide, we talked about combining data from multiple sources and then using temporal analysis to derive a meaningful conclusion with a certain pattern. So now if you take example of stock market trading, we can combine stream of online code data along with the stream of real-time news data. So, and then we can identify a specific pattern like news event concerning a specific company followed by major price fluctuation in the price of shares of this company within certain time frame like 5 minutes. And once you identify such pattern, you can make intelligent business decision to enable algorithmic trading, for example. So now this brings us to the most important point of today's discussion. What is Apama real-time analytics platform? Apama is a complex event processing and real-time streaming analytics platform which monitors rapidly moving event streams, detects and analyzes important events and patterns of events, and immediately acts on events of interest. As you can see in the picture, it has Apama development environment which is built right into SoftwareAG Designer now. Now it has a processing engine called Correlator and management monitoring tools, dashboard GUIs, integration adapter framework and analysis tools. So we'll go through all these details in the subsequent slides. So how does Apama receives the data? So you can connect Apama to any event data source, database, whether it can be messaging infrastructure or it can even be an application. So Apama integration adapter framework provides bidirectional connectivity with event sources and with your environment. It offers a range of standard adapters for capital market or framework for connecting with social media like Facebook or Twitter, LinkedIn, and it also supports standard-based connectivity like TCP/IP, JMS or MQ-based connectivity, JDBC, ODBC, file-based connectivity, or even web services. And if the out-of-box adapter that is provided with Apama is not available or is not suitable for your use, you can use integration adapter framework to develop your own adapter. Apama Studio, which is built right into SoftwareAG Designer, is the main entry point for Apama development. It's set of Eclipse plugins that provide multiple Eclipse perspectives. It has built-in EPL, which is event programming language, and Java editors to write your program, with the native benefit of Eclipse like syntax highlighting. It will flag a line if it contains syntactical errors, and you can use on the designer to develop, debug, and test your application with the help of available Eclipse perspectives. And later you can package your application for deployment using designer. Apama complex event processing engine is called Correlator, which supports efficient, highly scalable, multi-dimensional event filtering. Apama Correlator tracks inbound event streams and listen for events whose patterns match defined conditions. The correlator can monitor huge volumes of events per second. We will actually look at those statistics in the subsequent slides. The correlator works on patented HyperTree technology, and as a result of that, it can process millions of concurrent event queries, and also has a multi-language support. So it basically supports event programming language, which is proprietary to Apama, and it also has support for Java. So you can see how the correlator works. The correlator actually does not execute applications in a serial manner. It has certain components built into it. So Apama HyperTree is where the events are initially presented to the correlator, and they are immediately inspected. At this point, HyperTree knows that there is any value in processing the specific event, or it should just throw it away. And once HyperTree filters the event, it is passed on to the temporal sequencer, which builds upon the event matching capabilities. For example, if application seeks event A to be followed by event B within 500 milliseconds, the correlator will only concern itself with looking for event A and does not waste effort looking for event B yet. It relies on temporal sequencer, and that's the way it optimizes its operation. And a stream processor stores and organizes those windows of events and orchestrates the execution of real-time analytics over these event windows. Streams provide a very powerful and efficient way to use set of capabilities for defining real-time analytics and for looking for relational style patterns across multiple streams of data. So Apama supports multi-language programming models, as I mentioned earlier. So Apama EPL, or monitor script, is specifically designed for event processing. It is Apama's native event processing language. However, your organization and developers prefer to use mainstream programming like Java. Apama also has a support for Java API to make these features of correlator available in Java. So here is, like a small comparison of how a specific program to detect the stock taker will look like in EPL versus in JMON, which is Apama Java API. So one of the interesting things here when you choose what programming language to use is Apama EPL runs much faster than both C and Java. So this is because Apama engine compiles EPL program on every application startup as each program is injected in the engine. It uses the publicly available a low-level virtual machine compiler, and due to this, it can take full advantage of instruction set optimization specific to the CPU where that application is executed. So the Apama application written in EPL will always execute your code faster than equivalent implementation in Java or C. You can use SoftwareAG Terracotta Big Memory to store all the event data. This helps in scaling out your application. With this, you can have many correlators accessing this event data for scalability, because the event data is stored separately than the correlators. Parallel processing and failover are readily available out of the box, and each correlator acts as a hot standby if any other correlator in your landscape shuts down. You can also use flexible topologies in your landscape while designing the architecture. You can partition your application in parallel or serial paths across multiple correlators. You can implement partitioning at the adapter level as well, where the events are distributed across correlators. You can identify heavily threaded symbols, for example, and allocate more correlators programmatically for these symbols. Apama dashboard and viewer provides you the ability to view and interact with the applications running in a correlator. So dashboards contain charts and other objects that allow you to visualize the status, performance, and attributes of Apama applications, including any scenarios, scenario instances, as well as for sending events to the correlator. It supports graphical widgets and drag and drop development, and also provides you an API for web and client deployable visual control. So you can also expose this information to your, whatever preference you have for a GUI. Apama Event Modeler provides a graphical environment which you can use to create and modify scenarios. The scenario is nothing but a description of an application that will be deployed on Apama Event Correlator. It can pass through multiple states, and it can use rules to transition to different states. It is usually, typically useful for business and non-technical users. And Apama Studio, built on SoftwareAG Designer, will translate these scenarios into EPL for you. This is the administrative console, Apama Management and Monitoring Console, which provides a centralized control service to enable management and monitoring of entire Apama platform. So you can configure the management policies on the console and take the help of agents which are deployed to enforce these policies on your Apama landscape. So you can do a distributed startup and configuration of components, as well as health monitoring and failure detection. Management and monitoring console also helps you in component recovery and component shutdown. So just to wrap up the features and capabilities of Apama platform, it can help you monitor the stream of events using real-time dashboards. You can analyze the events and detect specific patterns with the help of Correlator engine. And based on analysis and detection, you can take appropriate action like triggering a business process or sending a message on fraud detection. So there are obviously other platforms available in the market, like Apache Storm or Esper. Microsoft has Stream Insight, IBM has InfoSphere Streams, but you can see how Apama provides distinct advantage over these due to patented HyperTree technology. It is way ahead in terms of strategy as well as current offering in the Forrester report. So it will help you achieve unprecedented performance at scale, multilingual support, and increased scalability with the same hardware and productivity development and visualization tools. So we will quickly look at how Apama works in real life. So this is a small demo actually which comes right built in with your designer. So this is how the dashboard will look like. here you can combine the certain parameters like location, temperature, humidity, visibility, monitor the historical movement of data, and then trigger specific action based on top of it. And you can use the SoftwareAG designer with the Eclipse, these plugins for Apama, and use the built-in adapters like web service client adapter. It also provides you additional adapters right out of the box to connect to any system of your choice. So these are like typical adapters that are available out of the box, and if one of these does not work for you, you can always use integration adapter framework to develop your own adapter. So as every year, Kelton Tech is sponsoring the Digital Business Days on October 3 and 4 in New York. So make sure you visit us there. If you have any questions, you can ask those right away to Jack, or you can see the live demo of Apama or any other SoftwareAG product at the Digital Business Days.
Thanks, Yogesh. It was great. We'll wait for a few seconds to see if any of the audience have any questions to put for us. And I think we can close after that. We'll wait for a few seconds, please. All right. I don't think so. Anybody has questions? But as Yogesh was saying, we have a few more webinars lined up. Please stay in tune. We have one September 23rd on the reference architecture, and on September 30th we have centralized management on web methods command central. So these are the two following webinars we have, and we are going to send this presentation whoever is interested. Usually the way we do is send a thank you note, and if somebody is interested, please get back to my email requesting for the presentation, and I'll be happy to share. With this, thank you all. Thank you so much for your time, and you all have a great day. Thanks, Yogesh.
Thank you.